Hello students, so welcome to Bhaskar online tutorial. In this class, we'll discuss about a new topic, that is vectors. So in this class, we discuss about what is a vector and what is a physical quantity and what are scalars and definition for vectors and how to represent vectors and types of vectors. So what is a vector? It is a branch of science. It deals with the study of measuring physical quantities. What is a physical quantity? So physical quantity which can measure. So how do we measure a physical quantity? In two ways. Okay, actually physical quantities are two types. One is scalar physical quantity, another one is vector physical quantity. What is scalar physical quantity? Scalar physical quantities have only magnitude. There is no direction at all. So for measuring a quantity, if we consider only magnitude without direction, such kind of physical quantities are called scalar physical quantities. So scalar physical quantities, there is no much to discuss because the to measure or to calculate the scalar physical quantities, we just use the mathematical operations like how we have four mathematical operations mainly. One is addition, subtraction, multiplication, and division. And how we do in our mathematics, we apply the same kind of mathematical operations for scalar physical quantities. So example, if you want to, so what is a scalar? It doesn't have direction, only magnitude. Suppose weight of an object or mass of an object 5 kg. So one object mass is 5 kg, another object mass is 10 kg. What is the total weight? What is the total weight of these two objects? Just simple 5 plus 10, 15. Okay. What is the difference? Difference of this one, 10 minus 5 is equal to 5 kg. Now, if one person weight is 2 kgs, then what is the weight of 5 persons? So one person weight is 2 kg, so into 5 kg, that is equal to 10 kg. Now, if 10 persons weight is 20 kgs, what is the weight of one person? That is equal to 10 by 2 is equal to 5 kg. In this way, we can easily measure the scalar physical quantities. Then what about the vector physical quantities? So first of all, we will understand the definition for vector physical quantity. What are vectors or vector physical quantities? So vectors are the physical quantities which have both magnitude as well as direction. So what is a magnitude? It's a mathematical value. So magnitude is nothing but a mathematical value. Suppose if a person is going due east with 5 meters per second, so due east, this 5 is the mathematical value and the due east is the direction. So this is the vector physical quantity. The person is going due east with 5 meters per second. So this meters per second, we already know that is a unit. So unit for is going with the velocity. Okay, that's why this is called 5 meters per second. 5 is the mathematical value. Meters per second is the unit. Due is the direction. So due east is the direction. So here we have given so both magnitude and direction. That's why this is a vector quantity. Okay. So we understood that what are vector quantities or vector physical quantities. Now, how do we represent these vectors? So there are two types. Okay, in vectors represented with alphabet and vectors represented with graphical or arrows. Like in the first case, alphabetically we represent like this. If A is a vector, So then we just use like arrow mark on the alphabet. Okay, A bar. We will okay, recall like that. Otherwise, in textbooks, generally they write like this or in bold letters like R. In this way, they will represent the vectors. So, in graphically, how do we represent vectors? Just simple arrow. This is the vector A bar. Here, what is the arrow symbol represents? It is a head and it is a tail. It is a tail point and this is a head point. The length between tail and head, the length between tail and head is called magnitude. Magnitude. So that's why it is having magnitude as well as direction. So these are called vector rotation or representation of vectors like this. So then we'll understand types of vectors. We'll discuss about types of vectors. So there are types of vectors. So vectors direction or vectors magnitude, according to the vectors direction and according to the vectors magnitude, we have so many kinds of so many types of vectors. In that, first one is equal vector. What are equal vectors? Equal vectors are nothing but they have same direction. They are, if two vectors are going with the same direction with the same magnitude, such kind of vectors are called equal vectors. Example, A bar having magnitude 5 meters. Another vector B bar is also having 5 meters. Both having the same magnitude and both are going with the same direction. These two vectors are called equal vectors. So, or are also called as parallel vectors. Both are going with the parallel direction. So, parallel vectors. So, another vectors are called like vectors. So like vectors and unlike vectors. Okay, like vectors. Vectors are having same direction but different magnitudes are called like vectors. Two vectors are having are moving in same direction but with different magnitudes. This magnitude is 5 meters and this magnitude is 4 meters. Such kind of vectors are called like vectors. Both are traveling in same direction. Next one is negative vector. Negative vector or anti-parallel vector. So negative vectors, so two vectors are moving with the opposite direction. So if suppose one vector is moving in this direction, another vector is going in this direction. Suppose this is A bar and this is minus A bar. These two vectors are called negative vectors. So the direction is opposite. That's why these are called negative vectors. Okay, then another types of vectors are so co-initial vectors. Co-initial, the name itself tells you that what are co-initial vectors. Co-initial vectors. If two or more vectors are starting with the same point, Such kind of vectors are called co-initial vectors. If suppose this is a starting point, the vector is going in this direction, the other vector is going in this direction, third vector is going in this direction. So they are going in different directions, but their origin point is same. Such kind of vectors are called co-initial vectors. So next one is coplanar vectors. Coplanar vectors, again the name suggests that what are these vectors. So if two or more vectors in the same plane, like suppose this is a plane, xy plane, suppose this is a xy plane. If two or more vectors in the same plane, all these vectors a bar, b bar and c bar, a bar, b bar, c bar are called coplanar vectors. Okay, next one, collinear vectors. If two or three vectors are traveling in same line, that is called collinear. Collinear vectors, like A bar, B bar, and C bar. Both, all these three are going in a same straight line. Such kind of vectors are called collinear vectors. So next one is unit vector. Very, very, very important. This one is important for IBE also. So what are unit vectors? Again, unit means one. If suppose if any vector magnitude is 1, so direction is specified and magnitude is 1, such kind of vectors are called unit vectors. It is represented with the cap. If any vector, if any alphabet having the cap, such kind of vectors are called unit vectors. So suppose A, if suppose A is a vector, on that A, on the top of the A, we have supposed to be write like this. Such kind of vectors are called unit vectors. So this unit vector is represented with the cap. So A cap, okay, like this we call. Okay, what are unit vectors? So I already defined that unit vectors is any vector magnitude is 1, direction is specified. Such kind of vectors are called unit vectors. If suppose unit vector A bar is equal to A bar by modulus of A. Otherwise, if a vector A bar is equal to magnitude of A into A cap. Here we see magnitude of A is nothing but a scalar. Scalar with A cap. A cap means unit vector, means 1, and direction is specified. And direction and magnitude, if you multiply, we get a vector. That's why, if anywhere in your problems or in some cases we multiply with the scalar, magnitude, only magnitude means scalar. So modulus of A means scalar. Scalar is unit vector. We will get a vector quantity. Any scalar quantity multiply with a unit vector, we will get a vector quantity. So this is the formula. A cap is equal to A bar by modulus of A. So this is all about unit vectors. In these unit vectors, we have another type of unit vectors. They are called orthogonal unit vectors. Orthogonal unit vectors. What are orthogonal? Orthogonal means perpendicular 90 degrees. Suppose it is an xy plane. This is x and this is y. Okay. On x-axis, suppose if you take another plane, another axis also, this is z. So all these are perpendicular to each other. Perpendicular to x and y is perpendicular to each other. Y and z and x are perpendicular to each other. Then how do we represent these orthogonal unit vectors? So they are unit vectors. They are represented with cap. But on the x-axis, we represented with I cap. On y-axis we represent with a j. Sorry. On y-axis we represent a j cap. On z-axis we represent a k cap. That means I cap and j cap and k cap are the orthogonal unit vectors. See the difference? Orthogonal unit vectors. So I cap j cap angle is 90 degrees. J cap k cap unit angle is 90 degrees. So that's why they are called orthogonal unit vectors. So these vectors are very important. In the term of position vectors, I will explain it very clearly how you use this I cap and j cap and k cap. So vector representation in the sense of vector representation and according with the coordinate system. So we require this I cap and j cap and k cap. So to write position vectors. So after this null vector I will explain. Then after position vector I will explain. There I will use this I cap and j cap and k cap. Okay, now these are orthogonal unit vectors. After orthogonal unit vectors we have null vector. What are null vectors? Null. The name itself again, null vector. What are null vectors? Simple. Null vector. Any vector's magnitude is 0. Direction is not specified. Such kind of vectors are called null vectors. Example, a complete rotation of an object. One complete rotation of an object gives a displacement is 0. Then such kind of vectors are called the magnitude becomes 0. Then such kind of vectors are called null vector. Here direction is not specified. Here I am not telling that there is no direction, and I'm not telling about there is a direction. Direction is not specified. Any direction you can take after that. That's why they are called null vectors. And unspecified direction is not specified, but magnitude is 0. Such kind of vectors are called null vectors. Okay, then after this null vector, very important position vector. What are position vectors? Very easy, simple. Suppose if I draw a point here, I want to ask you that what is the position of that dot? Is it easy to find the position of the dot? How can we say that the position? It's a complete so there is no plane at all. So I put a dot at somewhere else. So I asked you about that position. It is difficult. For that we will consider two vectors like this. This is suppose this is x-axis and y-axis. On x-axis we will consider one vector. Suppose a bar. So on the y-axis if we consider b bar. Okay, now this is the line which connects the position of the object. This also becomes a vector r bar, resultant vector. A bar and b bar is a resultant vector. This is r bar. This r bar is called position vector because in the coordinate system, a line which is drawn from the origin and that it connects the point the point what we have to find that position. Okay, here this is called position vector. See, this r bar is called position because this r bar represents the and touching this line touching the position, and it tells about the position vector. Suppose so this is the point on x-axis. On x-axis, this is 0, 0 origin. On x-axis, this is the x-axis, distance from the x-axis. This is the point, and this is the point on y-axis. Okay, so now how do we represent? Okay, suppose position vector a bar is represented with suppose axi. Okay, axi. Okay, b bar is equal to Bij. And I already told you that on x-axis horizontal vector is I cap and y-axis horizontal vector is j cap. Then r bar is equal to axi plus byj. If suppose in three dimension, if you take this is z axis, so this is k cap and c bar is equal to z. C bar is equal to CZK. This is equal to CZK. Then modulus is equal to modulus of R bar is equal to square root of A square X plus B square Y plus C square Z. So this is called magnitude of R bar. This R bar is a position vector. So it's a vector notation A bar, B bar, and C bar. And modulus of R means A square X plus B square Y plus C square Z. So how we got this formula in parallelogram law of vectors at the time of when a vector addition, I will explain this. So you will understand, we understood that what is position vector and how do we represent position vector. This is the representation of position vector. R bar is equal to AXI plus BYJ. A bar vector on x axis, that's why we have to add. So AXI, BYJ, C. AX is nothing but A bar magnitude. BY is nothing but B bar magnitude. CZ is nothing but Z bar magnitude. So A, B, C, I will take C. A bar, B bar and C bar. CZ is nothing but CZ is nothing but magnitude of C. Okay, here we represent the position vector R bar is equal to AXI plus BYJ plus CZK. In this way, okay, these are the types of vectors. So for IP exam also, null vector, position vector, and unit vector. These three are very important for 4 marks question. So many times in our exam, in IP exam, we got these questions. Okay, so I hope you understand. So types of vectors and what are vectors and how to represent vectors. Okay, then types of vectors. In our next class, we'll discuss about how to find the angle between two vectors. Okay, for today, so I'm ending here. Thank you. Bye.